Okay, the essential question for video 18. What are the different ways to find the slope of a line, and when would you use each one? So let's start by looking at the definition of slope of a line. Okay, so the slope is the ratio of the vertical change, the rise, to the horizontal change, the run, between any 2 points on the line. And so we usually number the points x1, y1 and x2, y2. So there's 3 different ways that we can look at it. Okay, the first 2, there's kind of 2 of them here, is rise over run, which some of you are familiar with, or you could look at it as the change in y on top or the change in x on bottom. Typically, we only use the rise over run if you actually have the graph to look at, where you can move from one point to another, going up or down for the rise, and then going left or right for the run. Most of the time when we're looking at it, we're going to be using this formula, plugging in 2 points that are given and calculating a slope. So this is our formula, m equals y2 minus y1 on top. You always subtract the y's on top. Those are the second numbers. Those go on top. Divided by x2 minus x1. So let's look at an example. We're going to find the slope of the line through those 2 points. So it helps if you label first what your points are. Try that again. x1, y1, x2, y2. Okay, so the first point is x1, y1. So we use the ones because that's the first point. And then on the second point, the 3, 1, we use the subscript 2 because that's the second point. So x2, y2 just means that's the second point. Always write down what your formula is so that it helps to make sure that you get your numbers put in the right spot. You're also going to need to know it for future classes, so this helps by writing it down every time you have to do the slope. Write down the formula. It'll help you to remember what it is, and that the y's go on top. So then next, y2 is 1, so we're going to start plugging in our numbers. Minus y1, which is 2, divided by x2, which is 3, minus x1, which is negative 2. Be extra careful with the minus and the negative parts. So it's 1 minus 2 on top, and when you have 2 minuses next to each other like that, a minus and a negative, that makes it 3 plus 2. So negative 1 on top, 5 on bottom. Our slope is negative 1/5. If you need to simplify the fraction at the end, always simplify. Make sure your slope is always written in simplest form. Example 2. So here's a graph. You could look at this as rise over run because it is on a graph. Always use the point on the left first, so that you can see whether it's a rise up, making it positive, or the rise is down, making it negative. So making sure you get it positive or negative is going to be very important. And then the run would go sideways. Now, as I said before, most of the time we're going to be doing these, I'm going to be expecting to see the formula, and you are going to calculate what the slope is. So those are your given points. So x1, y1, x2, y2, write your formula, y2 minus y1 over x2 minus x1, and then plug the correct numbers into the right spots. So we have negative 2 is y2 minus y1, which is 4. x2 is negative 2 minus x1, which is 6. So you have to make sure that you're consistent. Since I started with this point, x2, I start with, or y2, sorry, I start with the same point on the bottom for the x2. And then you're going to simplify this. So on top we have negative 6. On bottom we have negative 8. You have a negative divided by a negative, which makes that a positive number. You can also simplify the fraction by dividing top and bottom by 2. So that'd be a positive 3 over 4. Remember, you need to write your slope in simplest form. So a positive 3/4 is simplest form of negative 6 over negative 8. Now I have an extra question down here. If you switched which point we used as x1, y1 and x2, y2, is it going to change the slope of the line? So we can check it. So I used the 6, 4 as x1, y1. So this time I'm going to label 6, 4 as x2, y2. We'll label the other point, -2, -2, as x1, y1. So when we calculate the slope, we're switching which ordered pair we start with. So y2 is now 4 minus y1, which is -2. x2 is 6 minus x1, which is -2. That's 4 plus 6. Oops, sorry. 4 plus 2 over 6 plus 2. So 6 over 8, which is 3/4. Okay. So it doesn't matter which point you use as x1, y1 or x2, y2. You just have to be consistent when you're plugging it into your equation so that you are getting a consistent slope. It's the same line. It should have the same slope. It hasn't changed its slant at all. So it doesn't matter which one you label as x1, y1 or x2, y2. You should get the same slope. You just have to be extra careful with your positives and negatives along the way. Okay, one more quick example how we can use our slope formula. So if we're going to find the value of x so that the line that passes through the two given points, x9 and -119, has a slope of 5. So I know what slope I want. I'm trying to find what does this number have to be so that I get a slope of 5. So you label your points. So this could be x1, we'll do it that way, y1, x2, y2, and some of you might notice some solving issues as you substitute in your numbers and variables. Remember, you can switch them and use x2, y2 here and the x1, y1 there if you like. I'm going to go ahead and continue working with this one. Now, we want a slope of 5. Since that's my slope, that's my m. m is the slope. So I'm going to plug the 5 into the slope spot. y2 is 19 minus y1, which is 9, over x2, which is -1, minus x1, which is x. Now, if you remember back to standard 2, when we were talking about proportions, I can make the 5 into a fraction, and we can cross multiply. So 5 times -1 minus x equals 19 minus 9. And now it's set up as an equation that you should be able to solve. So we distribute our 5. So 5 times -1 is -5. 5 times -x, -5x, equals 10, because 19 minus 9 is 10. Then add 5 to both sides. Remember, we're always doing the opposite. So you have a -5 and a +5, so that cancels, means 0. -5x equals 15. And then you divide both sides by -5. So x equals -3. So the x has to be -3 so that the slope of our line is 5. Okay, so now would be a good time at the end of that example to write a summary to our two questions. What are the different ways to find a slope of a line, and when would you use each one? And then we'll do an activity on slope in class next time.